Today we're going to be talking about scientific notation. Scientific notation. Well, what is scientific notation? Well, it's not very long. I want to say very big. So scientific notation is a way to take a number that is very big or a number that is very tiny and write it in a shortened form. If I had this number, that's a very large number. We're talking about hundreds, thousands, millions, billions, trillions, quadrillions. So very huge, giant number. And if we're going to be doing stuff with that number, we don't want to have to write all those zeros out all the time. So to change this into scientific notation, we're going to go into that a little bit more in depth in a minute. But basically, we're going to take this part of the number, and I'm going to move the decimal point to the between the 6 and the 4. And to do that, I move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 places. So this is written as 6.4 times 10 to the 17. On the other hand, and again, if you don't understand that process, that's fine. It's coming. I just want you to see what I'm talking about taking a big number and writing it in a shorter form, or a tiny number with all those zeros before we actually get into any significant digits, write it in a short form. And so the same thing happens here. I'm going to put the decimal place right there. So I'm going to have 3.5 times 10 to the, we're going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So this number shortened in scientific notation becomes this. This number in scientific notation becomes this. The main thing that you need to understand about scientific notation is the exponent. The exponent holds the key. Here's what you need to remember. if the exponent is positive, the number is big. If the exponent is negative, the number is tiny. Now I wrote it big, but the number would be a tiny number. That is all you need to memorize. Positive exponent, big number. Negative exponent, tiny number. If you'll learn that, you can work any of these problems. So if we're going to take a big number and rewrite it in scientific notation, let's look at an example. The first thing that we have to do is we have to look at where is the decimal point right now. Well, right now it's at the end of the number. Remember, you can take any number and you can put a decimal point at the end of any number, anytime. Then what we want to do is look at these digits up here, and we need to write a number that is one digit, a decimal point, and then those remaining digits. This first digit has to be between 1 and 9. So in order to do this, I need the decimal place to sit right there between the 5 and the 6, so that this becomes 5.673. So we're looking at these significant digits, and we are looking at where does the decimal point need to go to so that the first digit is between 1 and 9. Next, we're going to multiply this by 10 to a power, and the way we determine the power is we count how many places we have to move that decimal point to get to right here. So I have to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 places to end up right there. 18 places. So this becomes 10 to the 18th power. 5.673 times 10 to the 18th power is this number right here. Okay. This number is not nearly as big as this number, but it is a big number. We're talking about hundreds, thousands, millions, billions. So to turn this into scientific notation, I have to have one digit, a decimal point, and then any other digits that might follow. In this case, I only have a 4 and a 7. So the 4 is going to have to be here. The 7 is going to have to be here. So I don't need any other places, just those significant digits. So I'm going to take the decimal point that is right here, right now, and I'm going to move it to between the 4 and the 7. We're going to count how many places we move it to get there. So it went 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places. So this becomes times 10 to the 9th power. Let's look at changing a tiny number into scientific notation. And again, if we go back up here and look, positive exponent, huge number. Positive exponent, huge number. Okay, so I have this number and I want to write it in scientific notation. The same process exists. I need my significant digits to be the first digit and then the digits that follow, however many that may be. It looks like there's 4 digits total, so I need 1, 2, 3, 4 spots. So that means I'm going to put that decimal place between the 3 and the 4. So this is going to become 3.496. Then we count how many decimal places we move to get that decimal place to the spot between the 3 and the 4. Well, it moves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 places. 17 places to get there. So this is 10 to the negative 17 because this is a tiny number. Tiny numbers have negative exponents. I'm going to not do 3. Let's do a different number. Okay, 0.000008. So that's a tiny number. It's not as tiny as this number. This is a really small number. This is small, but it's not that small. So I need a number, decimal, and a number. Well, there is no other digits. So that means we're not going to have a decimal point. We're just going to have a digit. I need to put that decimal point that's here after the 8. So this is going to just be 8 times, because there are no other significant digits. So I don't need to put a decimal or any other digits. There aren't anymore. But we count how many places the decimal point had to move to get there. And I want you to notice that as I'm counting, I'm trying to go up in between the zeros so I don't lose count. A lot of people do this: 1, 2, 3, 4, 5, and they don't count. They can't count those. They end up missing the count because they're not being careful about counting the number of decimal places. So when you see me do it, you're going to see me go 1, 2, 3, 4, 5, 6, 7, 7 places. So this becomes 8 times 10 to the -7th power. Negative exponents mean the number is tiny. Positive exponents mean the number is big. Let's look at going the other way, and then we're going to work some problems together. We call the number in its regular form standard form. So now we're going to have a number already written in scientific notation. And we want to know, what is the number? So here's what we do. We look at the exponent. The exponent is the key. Because that is positive, I know this is a big number. And the way I make this number big is I move the decimal place to the right. If I moved it to the left, it'd be getting smaller. It'd be 0.4 and then 0.04. We need it to be bigger. 43, 435, 4,350. We need to move it to the right so that the number becomes big. So here's what I do. I write my digits 4, 3, 5, and then I put, not necessarily 15, but close to 15 zeros, because I got to move 15 places. So I'm going to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 zeros. So that should be plenty. The decimal place right now is sitting right here. I have to move it 15 places to the right. So 15 places would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right here. So my number has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 zeros. So I'm going to write 4, 3, 5, and then 13 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we know that every 3 digits, we need to put a comma so that we know the place values. So this number put in Standard form is this number: hundreds, thousands, millions, billions, trillions, quadrillions. Oh, I'm sorry. I'm supposed to give you one in scientific notation. Sorry about that. So if I have 6.37 times 10 to the negative ninth power. The exponent is the key. My exponent is negative. That means that this is a tiny number. And the only way to make 6.37 get smaller is to move the decimal place to the left. So I know I need at least 9 zeros. So I'm going to write 0, 0, 0. That's 3, 4, 5, 6, 7, 8, 9, 6, 3, 7. Right now, the decimal place is sitting right there. I need to move it 9 places. So if it's sitting here right now, 9 places would be 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. So my number is point, and then I've got 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 6, 3, 7. 6.37 times 10 to the negative ninth is that number right there. Point 0.0000000637. Negative exponent is a tiny number. Okay, I want you to do that one, and then we'll check it. Ms. Billingsley, go back and look at that exponent. I'm still waiting on a couple of you to respond. Oh, is that everybody? 1, 2. No, it looks like I'm waiting on one. Then yep, still waiting on one. There we go. All right, let's take a look. First thing I see is a positive exponent. That means this is a big number, which means I've got to move the decimal place to the right to make 4 a bigger number. If I move to the left, the number's going to get smaller. So move to the right. So I need to write my digits, 4, 3. Notice I'm giving myself a little bit of space. And then I had what, 1, 2, 3, 4, 5 digits. So I need 6 moves. So I better put a couple of zeros on the end just to make sure. So that decimal place right now is sitting right there. It's got to move 6 places to the right. So 1, 2, 3, 4, 5, 6. It's right here. So that becomes 4, 3, 9, 6, 7, 2, 0. And then every 3 digits, we put a comma. Okay. And if you have decimal places after, that's fine. There's nothing wrong with that. It's just you typically won't see that written. They'll chop the number off right there. All right. Try this one. Okay, let's take a look. First thing I see is that I have a negative exponent. That means this is a tiny number. So the decimal place is going to be moving to the left. So I'm going to need some zeros in front of this 2. I see that I have to move at least 10 places. So I'm going to put at least 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 6, 3. Again, notice I gave myself some space. The decimal point is sitting right here. It needs to move 10 places to the left. So this is going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right there. So I'm going to have point. Then there's 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 zeros, 2, 6, 3. And if you put a 0 in front, that's fine. Sometimes you'll see a 0 in front, sometimes you won't. And so it becomes this number. Again, negative exponent, we ended up with a tiny number. Positive exponent, we ended up with a big number. So the key to these problems is looking at the exponent, looking to see is it positive or is it negative, and then determining, am I going to have a big number? Am I going to have a little number?
This has been a production of D&J Designs and MathMan 1962. If you like this video, click on the thumbs up. If you want to be notified when new videos are posted, click the bell. And if you want to see more videos like this one, click on the subscribe button.